Hi everyone, so let's take a quick look at the Mesh Python node. You can do some really cool stuff with it. So this is called a binary kite, I nabbed it. I kind of nabbed the idea from the internet. Don't tell anyone. But effectively, it comes from a web page for an app called StructureSynth, which you can use to create all sorts of weird and wonderful 3D objects based on rules. And actually, they're so cool. I think I'm going to do several of these. So I'm using some attributes to power, like how crazy it goes, and I'm not entirely sure I understood how it was made, just because I don't really understand the rules of how that app works. So I've guessed, and it looks pretty similar. So pretty happy. I think the only thing it doesn't do is scale. I probably should have done the scale. Never mind. We're here now. So yeah, let's get started with something a lot simpler though. So we will create a cube, and I'm actually going to turn this cube into a sphere, just because like a low poly sphere. So if I just go to the form menu after adding some divisions, 555, and then just hit sculpt, we get a sphere. So I'm going to go modeling menu, soften edge, just to get some normals there, and then to make the normals behave like it was a sphere, and then I'm going to delete history. So we've got a nice smooth sphere. So that I'm going to name sphere, and then we'll create a mesh network. So we go animation and mesh and create mesh network like so, and then let's just add a Python node. So we go add Python node. And then by default, we get some boilerplate and we get a little demo script. And what we do is we import the Mash Python helper class, which is called OpenMash, and then we create the the helper object for the for this node. So this node is mash1 underscore Python. So you can use the variable this node for just in your scripts here. If you want to use get attribute or set attribute or anything like that, then this node will provide you with the name of this node. So you get the frame number by with this helper function. So md.getFrame will get you the frame number, and then the count number of objects in the network can be got with count. And then what we can do is we can loop through all the objects in the network and then set their out positions, or you can set their out rotation or out scale or out color. What else can we do? ID, visibility, and then you can use things like the velocity to power things as well, so you can make things scale up if they go faster and all that kind of stuff, so you can have access to all of that stuff. And you can also do cool things like set the point count. So if we do md.set point count to say 50, and then I'm going to put that down here, and then hit the run button. So the play button here runs the script. So the first 10 objects had positions from the distribute node, and then after that there are no positions, so they're only getting their y value here. So actually what we can do is I can actually if I hit tab, so tab indents, and then actually also command or control right square bracket and left square bracket also indents and dedents. So dedents, is that a word? Yeah, so if we just hit X in here, we do that, then we get this. So there you go, we're affecting our objects. And we can also, like I said, you can use scale and rotation. So if I do let's do out scale equals I times 0.1 or something, and then hit play there. So we got Y scale increasing as the objects get higher. So there you go. So that's affecting the scale. So I'm gonna bundle up a load of scripts and then put them up. So we've got let's have a look at, say, something simple like a Fibonacci disk. So if I just hit play, here's our Fibonacci disk. It looks like not a lot, but if I just increase the point count, there you go. So there is our disk. Pretty cool. So let's make our sphere slightly smaller. There you go. And it's just a load of maths. You can get all this stuff from the internet, but I'll bundle them in the mash speak. Oops, what did I do? Here's a sphere. Here's a Fibonacci sphere. Yeah, okay. So like I said, I'll give these scripts away. It's just they're all dead simple. But I will just show you something else. So the radius here is being set by this value here, 20. So if I change this to say 30, we get a large sphere. So let's hook this up to an attribute so you can edit this and so you can animate this. So really important first step, select the Python node, because if you got here with a different node selected, then you're going to add an attribute to that node. So make sure you select the Python node, then go attributes, add attribute. We'll call this radius. You might want to give it a little pi underscore or something, just because, or let's call it something like pi radius, because you don't want to conflict with the name of an existing attribute on a node. So this is going to be a float, and we want a minimum value of say 1 and a maximum value of say 100. Just providing minimum and maximum values means that Maya will attach a slider to it if you use it in the attribute editor. So just press OK, and then if you go to the channel box, you can see we've got pi radius here. Yeah. So let's animate it. Let's animate this from 1 to say 25, like that. So there you go. So you can see that number's moving, but it's not being used yet by the node. So let's go into the attribute editor, and then we need to import the normal Maya commands. So we do import Maya .cmds as cmds. So this is just going to import the normal Maya commands library. So this script is run once, so it kind of like, we take it into the Python node behind the scenes, and then we just execute it once. So I mean, obviously if you have loops in here, you can run the code lots and lots of times, but yeah, generally speaking, this just gets run once, and everything gets flushed. So this object is recreated every frame. So if you need to save data between frames, like you need to save previous IDs or something, you need to save it to an attribute. So you can just create an attribute, like a vector attribute or something, or a string attribute, and save it as JSON. That would be really easy. And then just reload the data and then save the data again. So I highly recommend using JSON in Python. It makes everything really easy. Or you can do the old school way. You can use the Maya API to save it to vector arrays or whatever. So or to work with vector arrays. So it's all very simple. So if you're of a technical mind, these are all M vectors. So these are all API objects anyway. So yeah. Anyway, you can ignore that if you don't know what if you don't know what I said just means, then you can ignore it. So yeah, so we've got Maya commands imported. So let's get the attributes. So we do cmds.getAttr, and then open and close brackets, and then inside there we're going to put this node, which is the node name, plus, and then inside the quotation marks we're going to do .pi radius, which was the name of the attribute that we just made. So if we hit play to run the script, and then we just play the scene back, because this attribute's being read every frame, we have animation coming from a Python node. So pretty cool. Okay, so that's really kind of, just some basic working with the with the scene. I'm going to now show you the posh binary kite script, which looks like this. So now I'm going to make a cube, and I'm going to replace the cube on the repro mesh. So I'm going to select the repro mesh, and I'm just going to drag the cube over the sphere, and that'll swap those two objects. And then the cube that I've just made, I need to scale it up, like so. And then I'm going to give this a texture. I'm going to give it a texture of black, like so. And then I'm going to duplicate the cube, and then I'm going to give this a texture of white, like so. And then I'm going to add that to the repro mesh. So a few ways to do this. By the way, you can, if you had several objects to add at once, what you can do is you can just turn off this auto load setting here, and then you can just grab a load of objects in the outliner, and notice that the attribute editor hasn't updated, and then you can just drag them on. Or you can go right click, add selected objects, but because I'm only doing one object, what I can do is I can select it, then I can add select the repro mesh, and then just go add selected objects. So we've got two objects in our repro now. So on our mesh network, we can add an ID node then. Where is it? ID, there it is, and then just choose random, like so, and then we've got random colors. So yeah, so here's our binary kite. It animates. So here it is. I wasn't exactly sure how the whole thing worked, so I've basically where every point inherits the rotation, so it kind of it's as if every successive point down the z-axis is parented to the point that goes before it, and then every point is given a tiny little bit of rotation, so you end up with you have very little rotation here, but then this point, say down here, is inheriting the rotation of all of the ones that go before it, and so over time this builds up, and it kind of you get more and more compounded rotations as you go down. So I've defined a function in here which I'm using to create a transformation matrix, and then obviously I'm multiplying the current point by the previous point's transformation matrix. So, and that's all happening down here. So, I did this in a rush this morning, so I'm sure there's a better way to do this, but that's kind of what I'm doing at the moment. So I've imported the API here. This is the API version 2, which is much faster than API version 1. So, what else? Here we've got a few attributes, and we could just turn these into... a few variables, and we could turn these into attributes so that we can animate the so we can animate those settings, those aspects of the binary kite. So let's do that quickly. So I'll just add an attribute, and I'm going to call this like pi scale, and then we'll just hit OK, and then I'll add another one. I'm going to call this one pi curl, like that. And then in the channel box, I'll animate both of those at frame 0, like that. And then on frame 120, I will make those 120, in fact. And then set keyframes there, like so. So that's done. What we can do is do cmds.getAttr, and then this node plus open close brackets like that, and then it's dot pi. Whoops. Pi scale, and then same thing here, so cmds.getAttr, like that, and then if I hit play, woohoo, so I rewind, and then I just press play, and then we have our animation happening. Just as we did in the play blast I showed at the beginning of the video. So I know I've not gone through the scripts forensically, just because obviously I don't want to really do a programming lesson. But this is kind of how you use the mash Python node. So like I said, the important takeaway from the Python node is that you can set the point count with it. You can get the point count, obviously get the frame number, and you can get the node name, which you can then use to save attributes and read attributes. You can create your own functions in here, your own methods, and then use those. And you can import any Python module that you want to. So anything that you've got, any of your libraries or anything, you can just import those and then use those to create some cool effects. So you can import noise. This is using random. This is this binary kite uses the Python random module. But if you've got a noise module for Python, you could use noise instead of random, which would create a really cool effect, I think, much better than this. And so yeah, use the Mario API, use the Python API in here, that's absolutely fine. Just be aware that everything behind the scenes uses the, we use the Python 2 API. I think everything behind the scenes, I'm just going to load up the gubbins. So yes, everything's using API version 2. We've got some helper functions here, so I should probably, so it's worth mentioning that at the bottom of the Python script here, we're doing a set data, and set data, what that does is it just writes all of the data back to the node. So I showed you set point count. What you can also do is get fall off. So if you've got like a fall off attached to this, so you add a fall off object down here, you could do md.getFallOff and then like the index of the fall off, and the index is starts at 0, so it's if you have one fall off, then you would get, so you do md.get fall off. So sorry, hold on. So you do fall off strengths equals md.get fall off 0, like that, and that will get you the first fall off strengths, and then that's just an array of doubles. It's like, sorry, it's a Python list of doubles, or of numbers, sorry, and that would be a strength for that particular point in the MASH network, and then you could use that. You just, yeah, so I think that's all. I'm gonna call this like just a basic thing, so kind of just introducing you very politely to the Python, the MASH Python node. So let me know if you've got any questions, and yeah, hopefully that will just give you a flavour of the kind of stuff you can do with it. And yeah, just go nuts. You can put lots of Python in, and yeah, let me know what you create.